Hello everyone, this is Tudor and welcome to the Code Shepherds channel. In the first part of this video, we would like to make an introduction about the compilation phases, subject approach from the theoretical perspective, and then my friend Alex will explain in more details about this subject with examples in code. The compilation process of a program in C, but also in other programming languages, is in fact a process by which the code written behind the program is transformed into the so-called machine code, which is read and executed by the computer processor or CPU. In any programming language, this compilation process of the code on its turn is made of 4 compilation phases: the preprocessor, the compiler, the assembler, and the linker. In the above flow diagram, the following steps are taken to execute a program. Firstly, the input file, for example hello.c, is passed to the preprocessor, and the preprocessor on its turn converts the source code into expanded source code. The extension of the expanded source code would be hello.i. The expanded source code is passed to the compiler, and the compiler on its turn converts this expanded source code into assembly code. The extension of the assembly code would be hello.s. This assembly code is then sent to the assembler, which on its turn converts the assembly code into object code. After the creation of an object code, the linker creates the executable file. The loader will then load the executable file for the execution of the C program.
Hello and welcome. In this part of the video, we are going to discuss the compilation phases on a real-world example. So, the first phase that takes place when we press the compilation button is preprocessing phase. In this phase, our C code or C++ is going to be preprocessed. Well, this thing means that the code is going to be prepared at text level. We see here that we have some instructions with a hashtag before them. These are called preprocessor instructions. For example, include means that this line here will be replaced with the containing of the header.hash file. So this line here is going to be replaced with whatever header.hash file contains. It is just like copying all from this file and replace in this line here. More than that, in this phase, the macro are going to be replaced. For example, in header.hash, we have this macro called max and this macro called min. And in this preprocessing phase, these two macros are going to be replaced with their values. So when main.c file is preprocessed, it will result in a extended code with the extension .e. So we are going to have a main.e file, as we see here. And if we open it and we go to our program, we see that this variable here is initialized with value 100. So this is the preprocessed code, okay, main.e. And in our code, this variable here is initialized with the macro max. Also, in the place of this includes preprocessor directives, the preprocessor included the containing of the public.ash file. As we see here, we have here the declaration just before the declaration of these two variable of these two global variables. We have we have this type def in which we define data as being a structure with these two members, and we found this in most probably in a header file. So as we see here, before the declaration of these two global variable, we have the inclusion of the public.ash file. And let's open the public.ash file. And as we see here, this this header file contain this type def that we can find in the preprocessed file. As we see here, every C file after preprocessing state generates its own extended code file with the extension .e. So every C file that we have in our project after preprocessing state will generate its own expanded code file. The next phase is the compilation. The compilation is where the compiler do its own job. The compiler takes input the extended code that was generated by the preprocessor and transform this extended code into assembly code. Assembly code is another programming language very close to machine language. So after the compilation phase, every extended code is going to generate its own assembler code. As we see here, every unit generated an extended code and now generated an assembler code file. Let's take, for example, main.s generated by main.c, generated from main.e from the extended code, which is generated from the C file, from main.c file, and see what contain. As we see here, the assembler language is a low-level programming language, which is very close to how the computer executes its calculations. The next phase is the assembler. The assembler takes the assembly code, the S files, and transform them into object code. Object code is machine code. So in this file here, we are going to find a sequence of 0 and 1, which which represent the machine code. This is actually the code that is going to be executed by the processor. If we open a file like this, we're going to find this in obj file, obj folder. Let's take, for example, main.o. And as you see here, we see a lot of unprintable characters, because this is just a file which contain a series of 0 and 1. This is actually the machine code that pieces of machine code that are going to be put together by the next compilation phases, the link editing. The linker is going to link this object code into one executable file. As we see here, the hello.o file, the object file, is linked here into an hello.exe file. In our case, all these C files are going to generate its own object code. As we see here, every C file has its own object code. These object codes are going to be linked together in the last phase of the compilation process, called link editing. The linker is going to put together all this object code into one executable file. This executable file can be found here in the bin directory. And if we run this, we are going to see what our program is printing. And pretty much that's it. This is the whole compilation process of a C program. Thank you for watching and see you next time. If you like this video, don't forget to subscribe to our channel and share this video with your friends and followers. Bye bye.